Welcome back. And in the last video, we finished off saying the next classification model evaluation metric we're going to use is a confusion matrix. Now, if you're confused about the name confusion matrix, don't worry, it'll make sense after we go through it. So a confusion matrix, let's define it, is a quick way to compare the labels a model predicts and the actual labels it was supposed to predict. Now, in essence, giving you an idea of where the model is getting confused. Beautiful. Now again, if it's still confusing, don't worry, let's have a look. That's what we always do, right? We prefer to get hands-on. So from Scikit-learn, we're going to go from the metrics module, we'll import confusion matrix. And now we can create a confusion matrix by making some predictions. We've seen how to do this with the predict function. We're going to do that on the test data set. And then we're going to pass confusion matrix, the function confusion matrix, y_test, so the true labels, and the prediction. So this is the crux of what basically all evaluation metrics are doing, right? They're comparing the true labels with the predictions and giving us some insights on that comparison. And so if we hit Shift-Enter, we're getting an array back. What does this even mean? Just 4 numbers. Again, this is probably another thing that is easier to understand when it's visualized. One way to do so is visualize confusion matrix with PD crosstab. So let's see it in action. So we're going to go PD for pandas, crosstab, which is going to compare 2 different things. Y_test, we want to compare the y_test labels. Again, just another comparison between the true labels and the predictions. Y_test, Y_preds, and we're going to pass it row names is actual labels. Column names is, can you guess? If not, that's fine. No, this is short for col names. Oh, and this will be row names. So we don't need that S there. This is going to be predicted labels. Wonderful. So, what is going on here? Well, because we are comparing the true labels versus the predicted labels, this is what our crosstab of the confusion matrix is showing us. So our predicted labels, where our model has predicted 0 or 1, and our actual labels. So here, the rows are the actual labels, and the columns are the predicted labels. So in our case, where the actual label is 0 and the predicted label is 0, we have 22 examples. And then where the predicted label is 1 and the actual label is 1, we have 24 examples. And now if we total all of these up, before we check out the other 2, 22 plus 7 plus 8 plus 24, that's going to give us 61. And then if we remind ourselves of how many predictions we've made, there's 61. Why? Because there's 61 examples in the test set. Okay, so what are these 2 here? Right, so this is, let's read it out. So we got predicted label, where the model is predicted 1, but the actual label was 0. Okay. So that's a false positive. So there's 7 of those. And now we have a predicted label of 0, but the actual label is 1. So that's 8 examples of that. So that's 8 false negatives. And so hence, this is where the confusion matrix or the word confusion comes into confusion matrix. These examples here, this diagonal, is where our model is getting confused, aka predicting 0 where the actual label was 1, or predicting 1 where the actual label was 0. And a confusion matrix, we look here, where the model got the samples right is on the diagonal. So this here. So if we come to our confusion matrix anatomy, now we're going to replicate this in the next video. This is our confusion matrix anatomy. We see correct here is the diagonal. So this is true positives, true negatives. False negatives is over here, so on the right side of the confusion matrix, and the false positives is down here. Why is it a false negative? Well, the predicted label is 0, right? And the model has, the true label is actually 1. And this is a false positive because the model is predicted 1 and the true label is 0. And we've seen this before, what a true positive, a false positive, a true negative, and a false negative is. So how would we replicate something like this, which is again a little bit more visual than our crosstab? One way to do so is with, let's make a comment here, make our confusion matrix more visual with Seaborn's heat map. Huh? You might be going, Daniel, what the hell is Seaborn? Well, if we go here, Seaborn heat map, this is what I do whenever I don't know something. We go Seaborn heat map. We look at Seaborn, you might be asking, what even is Seaborn? Seaborn heat map. Plot rectangular data as a color encoded matrix. All right. Well, I'll give you the nuts and bolts. Seaborn is a visualization library that is built on top of matplotlib. And it's pretty relatively easy to use, but we're going to mostly just take care of the heat map function. So let's see it. So import Seaborn as SNS. And then we're going to go set the font scale of Seaborn, because it can be a bit smaller. Set the font scale, and we want sns.set. We want font scale. This is one of the easiest ways to visualize a confusion matrix other than a PD crosstab. So we're going to go create a confusion matrix. We're going to go confmat, short for confusion matrix, because we like to minimize the amount of keystrokes that we take. ytest, ypreds, pass it the test and predictions, just like we've done up here. And then we're going to plot it using Seaborn. sns.heatmap confmat. Oh, what? Module not found error. Drats, we can't use Seaborn. No, I'm kidding. So the reason why this module is not found is because you remember right back in the start when we created our environment using Conda? Well, when we did that, we didn't install Seaborn. And because Seaborn is built on top of matplotlib, we do have matplotlib, but we don't have Seaborn. We have pandas, we have Scikit-learn, we have Jupyter, but we're missing Seaborn. So how would you go about installing a module into your Conda environment, what we've got running in our terminal? Right, so this is our Conda environment running in our terminal. This is what's serving up our Jupyter Notebook server. How do you think you would install it? So one way would be to go to terminal, start a new window. We might go cd desktop ml course, where my environment is stored, sample project. I'll zoom in here so you can see it. Sample project, ls. So we've got our environment here. And then if we go conda env list, wonderful. And then if we wanted to activate it, we could go conda activate. We want our sample project. I'll copy and paste that. Then I could go conda install Seaborn. That's one option. We won't hit enter because I'm going to show you the other option. I'm going to show you how you can do it right within a Jupyter Notebook. This is a little bit bonus tip, right? We're doing this during a classification model evaluation video. But because we want to use Seaborn, let's see how we can do it from within a Jupyter Notebook. So this is something you might try whenever you get this module not found error. Say you come across some code or you come across a function that you want to use from a library you don't have installed. This is how you can do it from within a Jupyter Notebook to install it into the environment so it's ready to go. So after running this cell here, we're going to be able to use this cell if everything works to plan. Yes, prefix. So what this is saying is we're importing sys. This is going to let us access our system, aka our computer. And then we're running this bang function, which is just a way of telling Jupyter to run a bash command. So as if we did the same command here, ls. Now if we run bang ls here, it's going to show us the exact same output, but just from within a Jupyter Notebook. We'll get rid of that cell, we don't need it. And we're going to conda install, we're going to pass conda install yes. And prefix, we've seen prefix when we're setting up our environment. We're going to go sys.prefix. Prefix is just another word for path name, aka this thing here, path name. And then we're going to go Seaborn. So fingers crossed, if we run this cell, we should install Seaborn, and then we should be able to plot our confusion matrix using Seaborn's heat map function. So let's shift and enter. Oh, we're getting some loading. Beautiful. This is telling us what it's going to do. A newer version of Conda exists, thank you. Package plan added / updated specs, Seaborn, yep. The following new packages will be installed. Yep, Patsy, Seaborn, Stats Models. Preparing transaction, done. Tick, tick, tick. Moment of truth. Might take a little while to import. Oh, there we go. But it's not really offering much. Why is that? We go back to our keynote to see our confusion matrix anatomy. We want it to look a bit more like this, right? To get some numbers on there. Now, why isn't this offering that? Well, let's pause the video there. We'll continue on fixing up our confusion matrix in the next video, see how we can get some numbers on there. But take a little note of this one here. It'll be in the example code reference that you can use, but this is how you can install a Conda package from a Jupyter notebook into the current environment. And then you just put the package over here. All right, so take a quick break. There was a lot to cover in that video. I'll see you in the next one.